So this is the second session that we are doing as part of the CivilCAD University. Both of you that don't know, CivilCAD University is a series of sessions that we've launched 2 months ago. And if each 1 to 2 months, we intend to create the session. The session is a kind of a workshop of 2 hours in which we take a subject and dive into it. We take a subject and dive into it to learn more about the subject. Sometimes it's advanced things, sometimes it's basic things, everything. It's a mixed, but every time we dive into a specific subject, and today's subject is surfaces. When I say surfaces, is what sometimes people may call contours, but when we create contours, in fact, what we're creating is a kind of a surface. And so this is the subject for today. We talk about many things. We'll start with the coordinates list. We talk about features of coordinates list. Create a surface with the coordinates list, how to update the surface, how to define the boundaries, what is a break line, some advanced features of creating contour lines. We will show how to filter data from other surveys and create a surface out of it. And eventually we will also talk a little bit about LandXML. We show an example. So that's it. Just to remind you, surfaces is the basic. When I say basic, even if you are not a surveyor, if you are a designer and you want to design your own pipeline or roads or calculate volumes, earthworks volumes, making your surface accurate is everything, because based on the surface, the profile of your road will be shown, the vertical alignment and the cross sections. I mean, the existing situation. Same goes for pipelines. Earthworks, of course, if your surfaces are not accurate, then the volumes will be inaccurate as well. So everything is about surfaces. It's a basic thing and very important. We are covering many of you, and these are the contact details in case you need them. But let's not waste time. We like practical things, so I hope all of you can see my screen. And let me start by, first of all, it's very important. Let me start by the CivilCAD. By the way, I'm using a version, you can see version 11.1 from the 22nd of June, 2026. So this is the version. So sometimes we get people calling us or said, hey, I don't know if I'm working with the up-to-date version or whatever. You can check it. In fact, you can even go to help about, and you'll see here, 11.1, 22nd of June, 2026, which is, if you are going to our website, the official release. If you go to downloads, product, this is the place. By the way, this is a software update. We have launched 11.1 officially on February early this year. But then in June, a month ago, we have released a patch, an upgrade. So this is not a full installation. You'll have to install the setup and then run the update if you don't have 11, if you have 11.1. If you already have 11.1, just write the update. Download from here and write. You will not need a code here. By the way, in the next 2 weeks, we will release another patch with another update. Usually in an update, we have minor fixes. Here, for example, we fix something related to blocks in roads, but other things are coming very soon. So this is about the version. I'm working with this version, so everything that I'll do with this version. Another thing here is the AutoCAD which I'm using. I'm not using AutoCAD, I'm using ZWCAD. Those of you that don't know, ZWCAD is a competitor to AutoCAD, but for you, it looks the same. You see, it uses the same command, same things. So if you are familiar with AutoCAD, you can use ZWCAD. The good thing about ZWCAD, much cheaper, and in my opinion, better software because it runs much faster. Much faster. It runs much faster than AutoCAD. So, and it has some advanced feature that AutoCAD doesn't have. So this is for your own consideration, but I'm not here to talk about AutoCAD or ZWCAD. It's not so important. I'm here to talk about the CivilCAD itself. Okay, so all of you know probably that we have what we call projects. So I will work with a new project. I will call it CU session. And I have opened a new project. So the name of the project appears here. When I open a project, the name of the project appears here. One second. Okay, now what I'm doing here, okay. Here on the left, those of you that are not familiar with, we have what we call the workspace. You can close it or you can open it from here. And this gives you a full control of what's going on in your project. So I opened a new project. By the way, maybe I'm thinking about it. I should restart my system with, because someone wrote to me that the resolution is very high. So let me try something. I hope now you'll see better. Okay, now it's bigger. So we start saying that every job that we are starting has to start with a project. So I'm creating a new project. Let me open the one that I did before. Sorry, not this one. So again, CUS group session 4. Okay, good. So everything starts with the surface. But before we're going to surface, let's talk a little bit about the coordinates list. When we create a new project, CivilCAD automatically creates two kind of lists. One is the topography coordinates list and one is the design coordinate list. If I want to see the list, I can come to it, right click here and press open. Then the list will be shown here below. Again, click, right click, open. I can also do it from here, topography coordinates the same. If I want to do the design coordinates list, I'm going to design, right click, open. And then you see, it's changed to design. Again, you can see it here. This is what I'm talking about. Okay. So here I can see the coordinates list which I'm working with. Here below. Let's go back to the topography coordinates list. And this is an editor. It's very similar to a text editor. Those of you who don't know it, if when I want to click to type coordinates, I do it in the top line. There is a line here, editing line. And this is the list. So for example, point number 1, I'm pressing the space or tab to move to the listing or to the X. I will call it 300153 and 3000, and we'll give it an elevation of 100. And I'm pressing enter. And point number 2, it's improved 3020, 500, 3020, 500, and here 3000, sorry, and 10, 5155, and 102. And if I want to see the points, there are 2 options. One is to press the refresh button, which sits here on the top. The good thing about the refresh, it will refresh all the coordinates lists that you have. The bad thing is if you have many lists, many coordinates lists, and you've done, and you doesn't want that the software will scan the entire list and upgrade them, this will take much longer. So the fastest way will go to stand on the list here, right click, update. And that's it. Okay, so that's it. Let me just zoom to the extents. Okay, so these are the 2 points that I've created. The 2 points which I've created. So again, it can do it from refresh here or from the list here. Of course, I can change the name. I'll call it A and refresh, or update from here, and this will be A. Okay, or the same goes for the elevation. 57, update. Okay, what the software did, it created a block. This is a block. It has the 2 Z, the main Z and the things that goes after the decimal point at Z1, Z2, and it will have a name attribute. Okay, it will have a name attribute. Okay, this is the layer itself is civil, but each one of these will sit in a different layer. Civil 1, civil, there are other names, but civil names and so on. Another thing that I can do, I can also add a code. So if I come here and press, for example, put a code of 63 and update the list, then 63 is, I think it's a pine tree. Okay, it's a pine tree in this case. By the way, if you want to see the entire list, you can go to sit in your documents, CivilCAD 11, and codes. Here I'm using a set name main. So if I will open main symbol here, DWG. Okay, so this is the entire codes list. So this is 65, so this is 63 is this one. Okay. So everything is written here. Okay, let me go to my project drawing. In fact, if I will save it, it will now give it the same name. Good. So we learned a little bit. Codes is not the issue here, so I'm not gonna talk more about it, but generally there's an option to create your own set of codes here, topography codes, but this is not the session, so let me continue to other things. The size of the point, those of you that don't know, this is 0.5 meters, and it goes by the scale. So what did I do? I pressed the option button here of the topography coordinates list. And if I want, so 250 skeleton density will create this as 0.5 meter, and this is as 0.8 meter. So if I change it to 1,000, for example, then it would be 4 times higher, bigger. And I have to update. Okay, so everything is 4 times bigger. So this is about the scale. And what else? And let me go to the design coordinates list. I can also create an Excel file and create it, call it, and again, name it as 500, 501, 502, 503, and the coordinates will be 3,100, 500, 3,103.75. This will be 3,025.751, and the elevation will be, let's say 103, and this is 157, and this one is 102.111, and this one without an elevation. Let me just complete. 150, 3,070.756, 3,001.5, 100, 3.56. Okay, so this is a list that I've just created. Let me just save it. Okay, save it on my computer. I'll put it in the folder which I'm working with now. CCC projects. This is the session. I will call it my list of points. List of points. And I saved it. Going to the design, okay? Save it, I'm in the design. And instead of typing, I'm clicking here, moving to Excel, and picking the list. Okay, so this is the list. Here the elevation is not available. And if I want to see it, click on here, update. Here are the points. Here are the additional points that I just created. If you have any question up till now, you can write it in the, you know what? Write it in the chat if you have any questions. I will try to answer. If not, I will continue to the next subject. Again, in the chat, you can change, you can ask, and I will try to answer. If not, I'm moving to the next item. Okay, I don't see any questions, so I assume for now there are no questions. By the way, if I want to find the coordinates here on the map, I can just, for example, this one, 503, click on it, click this button, zoom to the point. Here it is. This is 503. Okay. Okay. Okay, guys. Let me continue. Again, if anyone have a question, put it, you can prompt it on the chat, and I will then try to do a next stop and answer the question. Okay, let's continue with this coordinates list, the topography coordinates. And by the way, if I want to have another coordinates list, I can click here on the coordinates, right click, create new list, and call it a survey 37 2026. And this is a new list. And I can open and start using it, and so on and so on. So again, how do I do it? On the group, right click, new list, and so all this list will be associated to this project. Okay. Survey as made. Okay. Okay, and so on and so forth. And again, I can move between them. You can see. I want to open this one. This is the one. I want to go back to topography. Okay. There's no limit. In fact, I can create as many as I like. Obviously, if I will have many, like more than 50, 100, depends on their size, it will become very heavy on my computer. So this is about creating this. But I will go back to my topography coordinates list. And what I will do now, I will add some more points. So I'll call it point number 3. And I will put it at 310 and on 5.76. And another one, 15. And dating, and these are the additional point which I've created. So these are the points which I'm talking about. By the way, I'm using a very big scale. Let me change it to, again, 250. Okay. Okay, so these are the 4 points which I have in my list. And what I'm going to do now, I'm going to add some more points. I can continue clicking. I don't want to use, later on I will use the list, pre-made list. But I can use another nice trick, is this button. You see here, it says pick, sorry, this list. If I create pick here and click here, there's a new point which was added here. You see, point number 1. And another one. Okay, and if I refresh, okay. And now I want to take all the points from here up to here and renumber them from 1. And that's it. So what I did, A did not change, but I selected 1, 2, 3, 4, and I renumbered them. And guys, if you have questions, just post them. I will later on do a break and answer. Okay. For now, all this, they don't have elevation. So let me start putting elevation. So 4, you know what? I will put it here. And number 4, I will rate it as 103. And number 5 will be, where's number 5? Number 5 will be 102.35. And number 6 will be 103.75. Wait, my mistake, sorry. This is point number 6, and it's 103.75. Let's just see what I've done. Okay, so these are the points, and I will take all these points together, give them the same elevation, top 175, and change maybe only 7 and 14. So 7 is here, give it 3 and 14 to create some contours. Okay, so this is this list of points that I have. Again, of course, I can type them, but obviously this is not the way I want to work. Usually I would just load them from here. So we saw how we can load it from a space delimited file with coordinates txt with space delimited, standard text file, area job, which is a CSV if you have comma delimited, Excel, and a lot of software equipment. Okay, let me answer some questions. Can coordinates be uploaded from handheld GPS and RTK, or should we manually input them? Of course, you can upload them. If you have an RTK or even handheld, you just download the list into a TXT file, which usually it comes with every RTK today, and open here and upload it. So you download it as TXT. Sometimes the name is XYZ. Sometimes the name is PNT. It's not so important. As long as you just come here, okay, you can use all files with space delimited and they will be uploaded. If they have comma between them, you can change their extension to be CSV and try to upload them as a CSV. If we add on CivilCAD 11, make most likely AutoCAD CivilCAD 3D. I don't understand the question, so anyhow, I don't understand the question, but CivilCAD is a civil engineering extension for ZWCAD or for AutoCAD. Okay. So we have a points list. So we saw a little bit how to use the coordinates, how to load them, how to enter them. We saw how we can identify a point. The next thing that I want to do is to continue to surfaces. Okay, surfaces. By default, since this is the coordinates list, topography list, recall that I've used this one, automatically there is a predefined surface for it named topography. So topography is automatically assigned to topography coordinates, and design is automatically assigned to design coordinates. If I want to create another surface, I can create another surface, new surface. I'll call it new survey. But it's not automatically linked to, for example, if I want to link it to this list, I click on it from coordinates list and select like this. And now this one is assigned to this. See, it's marked. So they are linked together. This is bind to this one because I did it now. But you see, topography, I didn't have to do anything. Automatically, it's assigned to the topography coordinates. Okay. So once the surface is assigned to the coordinates list, and as I said, the topography and design is automatic, I can create the surface itself. How do I do it? I can go to topography contours, or I can come here on the surface and go to right click and then go to properties. If I open it, I see the properties window of this surface on the right. For now, I see that the predefined is to show borders, to show the borders of my surface. There's no smoothness. Intervals are not predefined, so it defaults, so the system will select by itself. And later on, we'll understand the rest. So I don't want predefined. I want to use my own. I will use 0.25. And I press apply, and the system creates the surface. So this is the surface. You can see that there is a boundary to the surface here. Okay, it sits in its own layer. It's a polyline, but in fact, it's a 3D polyline. And you have the surface contours that have been created by this surface. Obviously, if I'll open the list and do a change, open the list, and for example, take this point, 10, and make it a little bit different. Update it. And update my surface. Okay, so the first surface change. Fine, good. So this is the surface. Now let's understand, since our subject is about understanding surfaces, let's understand what the software did. In fact, how the software create the surface and then display the contours on top of it. The software use what we call triangulation, also the terminology team. Triangulation or team is the same matter. It means that the software takes each three nearest points, and do interpolation between them. If I want to see the triangulation, I can click here on the right on show triangles, and then the triangulation will be displayed. So what I'm learning from here, let me just do something. This is the layer, CT. What I'm learning from here is that there was a triangulation between 6, 7, and 14. In fact, all of them are in the same elevation, so this explains why we don't see contours here. So let's take another one. 7, 13, and 14. So between this, they are the same. So the surface starts from here. So this triangle surface starts from here and goes 1 meter below to 110.2.745, meaning 3 contours at the intervals of 0.25. So this is what we get here on this triangle. So this is about triangles. It's very important. This is how the software knows how to create the surface and then, of course, create the contours. Again, software takes each 3 points, nearest point, connect between them, and create the interpolation accordingly. Obviously, if I do an orbit, okay, it will give me a better idea. So we know this was lower 117, and this is the surface that I have. These are the design points. So of course, they are not part of this surface. Questions so far? Guys, if you have any question, this is the time. You know what? I will, Nurit, if you can unmute the mics of everybody. If someone wants to ask a verbal question and not write, let's give you time. Please ask your question. Now is the time. You can write, you can ask verbally if you like, and I will try to explain. So if any of you have a question, please, this is the time. Don't be shy. Just unmute yourself and ask. If I'm talking too fast, I will try to slow down. Just write it in the chat that it's too fast for you. If you want me to repeat and a certain thing that I've done, I can try to repeat it. Of course, we have to balance between your questions and the time that we have. Okay. Klaus can ask how to delete triangles outside the polygon. Okay. I will answer the question how to delete triangles outside the polygon. Is it possible to integrate with the CivilCAD? This is already integrated with the CivilCAD. This is already integrated. So I'm working with the CivilCAD. So it's not a question. I'm already working with the CivilCAD. So what you see here is integrated with the CivilCAD. Okay, if you want to, okay. The question was whether I can decide to remove this triangle, for example. Or maybe there's another question. Is the triangulation of a point done between the closest point until all the points are done? Okay. Okay, first of all, good questions. I will start one by one. First of all, let's start with the last one. The question was how the software knows how to stop the triangulation. So the software goes to what we call a convex hole. Convex hole. This is the convex shape of the surface. The software doesn't know. For example, let's look at this one. There's a triangle, and let's say that my surveyor, which probably this is what happened here, survey stop here. So in fact, this is the boundary. But the software doesn't know it. So the software automatically creates this triangle, which is not something that I want the software to do. But the software doesn't know. So for the question, the software creates what we call convex. This is not convex. And therefore, the software doesn't know that the shape should not be convex. And let me try to draw something. So the software will not know how to do something like this. It will always close the convex shape. Example. Again, the software will always go and close this. So in fact, not even this convex. Refer to it as a straight line. So this is how the software continues the triangulation. Software doesn't know how to stop. Because nobody knows what is true or not is not true. Only the surveyor will know all your understanding. Okay. So, and then the question was different. How to remove this triangle? So the software CivilCAD does not allow you to just select a triangle and remove it. This is not possible. It's something that will probably come up.
Говно программа, блин. 30 лет назад возвращаться.
Guys, someone is in unmute. So the software doesn't know how to take a certain triangle and take it out. Just click this triangle, take it out. It's something that we might do next year. But there's another solution for what we see here. This is the boundary that the software created. It's the convex. But if I will use AutoCAD command and use pedit and use edit vertex, so this is the vertex, okay? And the next one is this one. I'm using AutoCAD command. And I will use insert and insert this one. You see the 3D polyline now of the boundary change, right? This is the new one. But for now, it's not a boundary of the surface. It's just a 3D polyline that I changed. If I want to affect it as the new boundary, I'm going to the right here. And instead of the extents, which is what the software use, I'm creating select, creating the boundary, which I'll change. You see how the software automatically tells you the points of the boundaries. See the points from the list. And if I press apply, then this one was removed. So let's do the same here for this triangle. Example, these two triangles. So I'm using pedit. We'll use this one. Edit vertex. Insert. This one. And we do insert again. Okay, so this is the new boundary. We select it and apply. And this is how I fixed my surface. So this is the way to fix the surface. Again, I'm taking the convex hole, the 3D polyline that the software created. I'm doing editing by object snapping to the points, selecting it on the right, and that's it. And then the software will create it accordingly. So the surface will become accordingly. What was the question? Collected data from solved devices, both topography and design points will be collected together. And CivilCAD can be able to differentiate between topography points and design points. Okay. Very interesting questions. Okay. The question was, by the way, someone asked me before a question which is quite odd. What is the difference between ZWCAD and CivilCAD? ZWCAD is the drawing environment. CivilCAD is the civil engineering extension. So again, ZWCAD is just for drawing. It's like AutoCAD. And then the extension, the CivilCAD is the civil 3D extension. So someone asked, I have collected all the points. Let's assume, okay, let's do, okay. The question was like this. This list, you know what? Let me try to do. It's a very interesting situation. Let's put additional point here. Okay. Okay. So let's assume that this is the list. You know what? Let's put additional points. I want to demonstrate the use case. And someone says, yeah, but I have a mix. Guys, unmute yourself.
Joe, do to take it. Nani editor.
Guys,
Hapana. Niliongea naye.
Noel, can you unmute? Can we use CivilCAD as a plugin into ZWCAD? Of course, this is what I'm doing here. Okay, to your question. The question was, how can I, okay, this is the list. I've uploaded my list. This is the list. But someone said, but this is a mixed list. Some of the points here are for topography and some of them of the design. I want to separate them. So okay, first of all, I need to know which one are for topography design. I can, for example, manually select them. For example, point, if I know that point 15, 13, 18, 17, and 14, so I can take point 15, copy, go to the design coordinates, and paste. Okay? So now 15 is sitting in the design list. Okay? I just copied. But this was done for only a single point. If I want to take a group, let me go back again to the topography and select a group from here till here with Shift. But I can also do it geographically. How do I do it? I'm going here to the locate, and the software asks me, what do you want to locate? Polygon in, polygon out, or a single point? What are you trying to work on? So I said, I want to work on a group, a polygon of points. Polygon in, I. Okay. Now I said, can you select the polygon or you want to draw the polygon? Do you have a polyline of the polygon? I said, no, I want to draw. So this one from here, all the points which are sitting here, and C to close. See what happened. The system went through my list and highlighted all the points within this polygon. 17, 18, 15, 14, 13, all the points. The rest of the points are not highlighted. See, these are not highlighted. Only those points which are within the list. Then I can do the same trick. Copy, go to the design coordinates, go to the last one, here for example, and paste. So all of them were copied here. So now I have them in the design. And then I can go to the topography and remove them from the topography. Delete them. Let's update. So what I've done, I've taken all these which I've marked are now in the design list, and all these are in the existing on the topography. And of course, in the design, I can create a new surface to design points. Let me go to the design points. Obviously, they don't have elevation, so let me put some elevation to them. I don't know, 100, 99, 158. By the way, if I'm using the arrow down, it will stay always in the same column. If I'm using enter, it will not. On my keyboard, I mean. And update the list. And then I want to go to the design surface, properties, and create triangulation on it. And then I have two surfaces, the existing and the design. So I hope this answers your question. There are other methods, for example, I'll give you another example. And this will be the last one that I'm showing today. Let's say that 16, 19, and 20 are part of the survey of 30. I want to copy them to this one. And all of them have elevation of, let's say, just for our use case, 95.8. And I marked them when I went to the field, gave them code. All of them, I called them S3007-2026. Oh, it's too much. As made. I gave him a code. Again, the code, I didn't put it here. I put it in the field in my RTK. And when I download everything, what I'm doing, I'm clicking this nice button, find. Then I find all the points with code ASM. Find all. You see, so the system, traced all the points with ASM, and I'm using the same trick. Copy, going to the list which I want. Okay, copied them to here, going back to the same list, the first list, and remove them. Delete. That's it. Now I'm in a new layer or a new group. See, we isolated them using their code. So these are a few tricks which I've shown. I hope. Can we please repeat how to edit and fix the boundary? Please repeat. Okay. Okay. Guys, we will circulate the recording. We will circulate the recording. So I'm a little bit short of time, so I want you to just see the recording and then see how we can change the boundary like I did. But generally, it's just p-edit the boundary, change the boundary, and select it from here on the right. Okay. Now, next item. So we talked about boundaries. By the way, there's another method. Okay, we see we have, let's go to the design surface. And let's give it in intervals, also 0.25 like we did for the existing. Okay, this is 0.25. And we have the same problem here, right? Let me show the triangles. We have the same problem here, right? What we can do is we can use what we call maximum interpolation length. What is maximum interpolation length? Maximum interpolation length tells the software, go on the triangles that sits on the boundaries. And if any of the edge is longer than the parameter that I put in the maximum interpolation length, remove this triangle. So for example, the distance, let's give more or less, the distance between here and here is 60 meters. So if I put here 55 and apply, the system will remove, you see, it removed this, which has an edge, a side of the triangle, which is longer than 55. But also this one was removed because probably it has the same thing. Meaning from here to here, it's probably also bigger than 60. So what I'm learning from that, maximum interpolation length usually works And people ask me, so how much do I put? 50, 30, 60? Well, the answer is it depends on your survey. But if I assume that my surveyor or myself, I put a point each at least 25 or 30 meters between them, then use, let's say, 35, a little bit bigger or higher than the distance that you use to do the surveys. And then the triangulation will move automatically. By the way, you can use the maximum interpolation length and still use the same method. So, okay, I have this boundary. I can take it, again, do p-edit and remove additional. For example, here, I don't want this one. Okay, so I'll do the same thing. P-edit, edit vertex. So insert. And this is the new boundary. I'm selecting it. Not this one. Oh. What did I do? Okay, I did a mistake. So this is the one. Edit. Edit vertex. And it's not an insert. I have to break it, and because it's not in the middle. This is what happened. Okay, it will take me time, so I don't want to do it. But in short, if I break it and fix everything to go to here, and then select like I did before, then fine. I can also refine my own boundaries and remove this triangle outside. Okay. But it's good because you ask very good question. It shows that you understand what I'm talking about. The next item that I want to talk about is what we call breaklines. Breaklines. So the terminology is breaklines, and for that purpose, I will create a new I will create a new sorry about that. I will create a new project because I want to demonstrate the problem. I have pre-created, I'm specifically creating the list as we go because later on we'll go to bigger project, bigger files and so on. But I'm now using small demos just to explain to you more. Okay. And let me start with base, I'll call it station 1, and it will be on 1000 on 1000 at the elevation of 100. Okay. Okay, let me start with this one. And let's say that I have a road here. So from this station, I start surveying. 1. This is right side. This is the sidewalk. This is the bottom of the sidewalk. This is center of the road. This is other side. And I'll do the same here. Side of the sidewalk. Top of the sidewalk. Bottom of the sidewalk. Center of the roads and left side. And the last set is here. Point, sidewalk, bottom of the sidewalk, center here. See? Okay. So these are the points. And now elevation, let me give him elevation a little bit. So what I would do, first of all, let me make them smaller. Let me see. So it will be easier for me. Okay. And I will take all this point here, give them the same elevation. So I'll do locate, polygon in I, this one, this one, this one, this one. Okay, so all of them are highlighted in the list, and I will give them elevation of 101.5. Okay, good. So all of them are 101.5. Good. And then all this again. Okay, polygon in from here, sorry, here, 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 and close. And I will give all of them an elevation of a little bit lower, 1.1.3. Let's see. Good. And now the bottom of the sidewalk. So it will be okay again in sorry, from here to here, 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 and all of them would be 15 cm lower. So if this one was 3, so this one would be 100.15. Okay. Okay. So again, this is the one side of the sidewalk. This is the other. This is the inner part of the sidewalk. This is the bottom of the sidewalk. Now for the rest, let's put all of them in the same elevation to save us time. Locate in. And all of them will be 101.75. Good. So my list is ready. My list is ready. And now I'll create a surface. So go to the surface properties, and let's use 0.1 and apply. Okay. This is what I received. This is what I received, which for me, it's quite odd. It's quite odd because, first of all, I don't want this one to participate. This is the station where I did my, I put my total station. So I'll go to the topography points. I will look for this point in the list. I can just press locate here. Here it is, ST1. And instead of, okay, I can remove it. by pressing delete, or I can freeze it. Freeze is here, this button. If I freeze it, the system will put FR in brackets before. And then if I recreate the surface, the system will know how to ignore it. So it's still in the drawing, still in the list, but it's freezed. It's not been used. It's been excluded from the surface. Good. Correct. So this is better, but I still see some problem here. The sidewalk supposed to have, look, this is all 1015, and all of these are 101.3. So there's a 20 cm elevation between these two, but the lines are not straight. They're supposed to be straight. What I want to say, and let me try to draw, I was expecting to see straight lines like this as my contour lines. But I'm not seeing them straight. I'm not seeing them straight. And the reason, and I'm trying to understand the reason. And the reason is because the same triangulation that we talked about. If I do now short triangles, you see something very, not strange, but obvious if you come to think of it. Let me take the layer and change it to yellow again. Okay. So see what happened. The system didn't know that there is a fall, that actually this point here, okay, 0.7, 0.12, and 0.2 are the top of the sidewalk, top on this side. Therefore, automatically create this strange triangle because 1, 2, and 3 are the nearest points. If they are the nearest point, then the system will create a triangles. The software doesn't know that it has to stop here along the top of the sidewalk. To stop along the sidewalk. We call this problem the breakline problem. The breakline problem. I will explain again. My assumption was that since this one, and this one are in the same elevation, and this top, and top are in the same elevation, I will have straight lines. Here, especially here, you see they are breaking. And they are breaking, you can see it immediately. They are breaking because of this triangle. This triangle was created because the software, we talked about it, take 3 nearest point and do a triangulation. The software doesn't know that there is an end of a sidewalk here. How to solve this problem? We are creating a breakline. What is a breakline? A breakline is something that tells the software, you do triangulation till this breakline from one side, you do triangulation to this breakline from the other side, but you don't cross with your triangle this line. You do a break. So this is the mathematical explanation. Physical in the field, we usually take and create breaklines along a stiff fall. So you might say, but this is not a stiff fall, this is 15 cm. It's a stiff fall because comparing to the difference here, which is probably a few centimeters, it's stiff. So we'll do it along cliff. In roads, we'll do it when in the bottom of the ditch or the top of the ditch. We'll do it along a sidewalk like here. How to do it? Let's do it together. So the subject now is breaklines. We are talking about breaklines. We defined the problem. We saw it physically here. And now let's look for the solution. Before I'm going further, there are a lot of questions. Let me try. Can you please repeat how to edit fixed boundaries now? Will you have a copy? Will like to have a copy, please? Of course. How can I get the software ZWCAD? There's no such thing ZWCAD 11.1. You talk about CivilCAD 11.1. CivilCAD 11.1 works with all the ZWCAD. You can see it here. From 2020 and up. So if you buy ZWCAD, each of the ZWCAD 2020 and up, this same CivilCAD 11.11 will work with it. In this case, I'm working for 2026, and the release that we'll do next month will add 2027. Same goes for AutoCAD. If how to buy it, you can buy directly from ZWCAD. If you want, you can write us an email and we'll explain. You must, okay. So this is for Williams. You must make a line, of course. I mean, how much will it cost me? Okay, Williams, not now. Send us an email and we will answer. You send to sales@sivandesign.com, sales@sivandesign.com, and we'll reply. Now, so I want to create a break line. So the solution is creating a break line. There are certain methods of how to create break lines. There are several methods of how to create break lines. If I'm the surveyor and I know I have a sketch from the field, I can use this sketch. For example, I can create a break line going from 2 to 0.7 to 0.12. I'm going to the surface. This is the property. Right click, set break lines. And I said about two methods. One is to take it from a layer in the drawing, or to actually create it, what we call lines list. So I'll go to lines list. This is the first method that I will show. On the right, I see a window. The window is divided into two parts. The lower part is the lines list. The upper part is the definition of this specific line. In this case, line number 1. But if I create more, this is line number 2, 3, 4, and 5, so on and so forth. Okay. Let me mark all of them, create, delete, and start from the first line. And since I have a sketch, or I know that it starts from 2, I can come here to line, type 2, go to 7, and go to 12. Okay, so the software created, you see this drawing? So next, let me take the break lines and change them. Sorry, the triangles, so you can differentiate. Let me take the triangles, make them greenish, no, reddish, like this. Okay, so when I entered 2, 7, 12, the system automatically create a line between 2, 7, 12. And to set it, I'm pressing this, set. That's it. Now it's a break line. This is one method. Okay. And now for method, let's say I want to create a break line between, in the center, 4, 9, and 14. And from the field, when I created it in the field, 4, I give it a code. Center line. 4, 9. Let's say it came from the field. Okay? When I download my points, I put it in the field. right? In the field, I give a code to each of this point in my RTK or total station. Okay. Okay. I'm going again to the break lines, right? Break lines. Okay, it's already open on the right. I don't need to reopen it. I create a second line, and after this, I'm connect all the points with code C double dot CL, code CL. So the software automatically create a line from 4, 9, and 14. So the software scan all these points which has CL as a code and create. How did I did it? Again, C double dot. Let me do it again. Let me remove all the points. Okay, and C CL. C double dot CL. C is, it means code, and CL. Of course, C is the code itself. And that's it. And then I have to set. So I have two break lines. This break line and this break line. Perfect. Let's update the surface. I go to the surface. I can click properties and open it on the right, or I can just click update surface. That's it. Something went wrong. Something went wrong. Okay, sorry. I did not set my first one. It's my mistake. So again, it's from 2. In fact, I can even click here on locate instead of entering the number. It's a third method. I can go from 2 to 7 and to 12. Create it. To somehow I'm doing something not good and I don't know what. 7, 12. Okay. Somehow it doesn't work for me. I don't know why. So I use another method. I will just draw it and filter. So we saw a first method. The first method is using the code. Second method is using the numbers. Third one is using locate. And the fourth one is just draw them and filter. What do I mean draw and filter? I will create my own layer. And I will call it my BL, my break line. And I'll make it the current. And what I will do a 3D poly. I'll draw a 3D poly between this point, and this point. I created a break line. And in fact, I'll do another break line also on the bottom. Again, 3D poly. No, this is not a 3D poly. 3D poly. From here to here to Where is it? Here. So these are the two break lines that are sitting in my BL. What I'm doing, I'm clicking this button, filter. And the software asks me, which layer do you want to filter? I'm saying I can look for it in the list, or I can just pick this one. So this is my BL, and these are polylines. Good. Apply. Overwrite exist line. Okay. He said that there's already a line which exists in my list. You remember the line that I created in the center. Do you want to overwrite it or to add? I said add. I don't want to overwrite. So two were filtered. We know because we created two. So see what we have. Two. See? The software created the first one which we had, and 2 and 3, which was just filtered, and the software automatically update the names. Let's see what happens if I update the surface. Perfect. Now everything is okay. See what happened. The break line, let me take the break line. It's sitting in a C topo BL break line. It's great. I will make it yellow. Again, yellow is something that everybody can see. Okay. You can see it here. This is one break line. This is second break line. You see what happened? Before, this triangle went to here. It crossed here. But now there's a break line. So this triangle stopped at the break line. The same goes here. This triangle, you remember there was an ugly triangle going from here. It is not here anymore because there's a break line cutting the continuation. Now, if I will, freeze the triangles, you can see that my contours make sense. They go from top going down. So we talked about the break line problem and how to solve the break line problem. I hope this gives you a good clue of how to work with break lines. If you have a question, all right, okay. Unless you have question, in fact, I don't have much time, but still post your question because we only have less than half an hour. But what I will do now, I will show you some other tricks on how to create surfaces. Let's assume that I'm not the surveyor. I received a DWG from another surveyor. Okay, so I create a new project. And I will create CUS26. It's a new project, which I've just created. What happened? Yeah, for your questions, 1 second. Yes, we are giving the recording. Don't worry. Sorry, it's my mistake. I closed the software. Let me reopen it. Neither if you have question, this is the time. If you have question, this is the time. Okay, so the next thing on the table is, again, I've received a DWG from another software, and I want to use it to create my own surface. Why I want to, let's assume I receive it with contours and everything, but of course, okay, let me explain. Let me create the project. Okay, I'll call it 6. And let me take a DWG. Okay, so I have here in my project, I brought a, where are we? Here. This is a DWG from a surveyor from 21. Okay. Okay, it's a DWG of a survey. Someone did this survey for me. And now I want to create a surface. Obviously, this is not a surface. I cannot do volumes. I cannot do design a road. I cannot do pipelines. I cannot do anything because this is not a surface. This is just a DWG. In fact, this one is not even in my drawing. So what I will do, first of all, I will put it inside my own drawing, my own project. Okay? How to do it? I will select all, Control A, then Control C, copy everything to the clipboard. Go to drawing 3, right click, clipboard, paste to original coordinates. So what I did, I just copied the entire drawing into my own project. Okay? CSU, whatever. In fact, I can close this. I don't need it. Okay. And this has a lot of points. You see? But of course, these are not my points. I don't have the survey. I only have this DWG. But we already saw that to create a surface, we need coordinates. We need coordinates. Sometimes we need breaklines. So the question will be, how can I use this DWG to create my own surface so I can continue to do designs on it or volumes calculation? How can I convert it to a CivilCAD surface without having the coordinates list? So what I'll do, I will do some kind of reverse engineering. I will take this DWG and convert it into coordinates list. And based on this, I will create my surface. Let's see how to do it in actions. Okay. But when someone asks a question, sales@sivandesign.com is also for support. If you need support, you can also write to sales@sivandesign.com and we are replying. Usually we reply, we definitely reply the same day, but not all the time we immediately reply with an answer. Depends on the problem, the magnitude of the problem. Okay, coming back to my question. I have this list of points, but it's DWG. But let's see what this point is all about. Properties. Well, I see it's a block, and it's a block with an elevation. It's a block with an elevation. You see? 59259. Then I'm going to a very nice thing that we have in the CivilCAD called filtering, general filtering here. By the way, we use something similar for the breaklines, but here we are doing it for the points. I'm going to the filtering. And I'm telling the software, take this list, this layer, which the name is M1502, okay? And it's a block. So look for the insertion point of the block on this layer. And when you are doing this filtering, send it to the topography coordinates list. Okay, let's open it if you want to see the results. Okay, to this list. And I press apply. What will happen now? Sometimes it takes time, depends on the size. This is quite a big file. You can see down below. It's scanning this entire layer, M1502, looking for all the blocks in this layer, taking the blocks and converting them into coordinates list. And add them to the topography coordinates list, which you see below. So let's wait. Okay, so we see it's quite heavy. And again, it depends on the size, not just the size, also the type of the drawing, the nature of the objects inside. Sometimes it can be very fast, sometimes it can be slow like this, sometimes it can even take a few minutes. Here we are waiting for about a minute. Good. You see, I got the list. The list is here. The total number of points was almost 11,000, 10,944 points, which were and we have the list. But, and let me, like we did before, update them on the drawing. So I expect to see points. Yeah, you see on each point that was in the DWG, now CivilCAD creates its own layer based on this list, which is good. But before I create the contours, I want to show you something. If I do an orbit here, okay. So you see that some of the things are falling on Z0, which means that if I create now a surface, you know what? Let's create a surface. It will be easier. Let's create a surface, and for instance, just create it even each 5 meters. It's not so important. And show me the triangles. And use maximum interpolation length from 60. Okay. Now the software trying to create the surface. Whoa. See what happened. You see? That means, I'm telling you straight ahead, that some of the points which were filtered went into 0. You see this point? This is 0, 0, 0, 0. As you know, 0 is also an elevation. It's not a freeze point. So the software automatically did interpolation between this into 0, and obviously this is not a good surface. Okay, from top it will be like this. See? It goes from 600 to 0. Obviously, this is not a good surface. We have few problems like this. So some of the points in this drawing, not because of me and not because of the software, because this was what the solver that created this drawing prepared, were in 0. How to remove, how to fix it? How to fix it? I'm using again this balaculus that I showed you before. And I tell the software, find all those elevations which are exactly 0. Or I can even do something else. Water elevation, but at most, we know that this project is more or less in 600 meters. So let's take 400 meters as safety and find all. You see what happened? The system went, the software went here and marked all the points which are below 400. In this case, a lot of 0. See, all of this. Well, I don't know, they are not together. Here there's a big group together, but probably if I scroll a lot, you see there's a break and probably there are more later on. Okay. Once the sifter found them in the list, I'm clicking erase. That's it. I've cleaned my list. Let me take it down again. I've cleaned my list. I'm updating my points. You see all the zeros supposed to disappear. Yeah. And I'm updating my surface. That's it. All those ugly things, even if I go to orbit, we don't see them anymore. Okay, this is not a, this is something from the drawing. It's not even a layer of CivilCAD. I don't know what it is. It came from the drawing. M159. I don't care about it because I didn't use it. But you see that my surface is now good and ready to go. By the way, one of the problems that can occur is that if you are filtering points and you are not filtering breaklines, you'll have the same problem that we saw before with the breaklines. So for example, take this road. You see these triangles. You see this triangle? It's crossing this side of the road. This is the side of the road. This line. M2407. What I can do, I can filter this as a breakline. But before that, I want to see if it's in 3D. Unfortunately, no. The elevation is 0. So if I would filter it, it will not give me anything. I cannot use it. I can take it and then project it into the elevation of the surface, but even then, it will not be truly accurate. So in this case, maybe since I don't have 3D lines that represent my break lines, of course I can create it myself, but if I want to use what is already on the ground, I can use another method. Let me remove all the points on the list. And now, instead of filtering the points, I will filter the vertex of the contours. These are the contours which were created by the solver. See this one. He named them cont 50, cont something, cont 100. How do I do it? The same thing. General filtering. And I'm selecting. I want to use this, and this. And also this. I don't know if this is, yeah, and this one. See, Con 25, you know what? Even this one I will mark it. All this list. And put them in the list in mind. Okay, again, it will take time because it will now filter all the 3D polylines that we have here in 4, 1, 2, 3, 4, 5, 5 different layers. So it can take up to, I don't know, 1 to 2 minutes. Because it's quite a heavy process. Not so heavy, it's have to scan a lot of data. So. And from each polyline to identify the vertex. Okay, we are halfway there. Be a little patient. Still working. Okay, someone said, what if the levels are not in blocks? Stanta explained such a problem, I assume. Okay, we can filter also text, or we can filter like I did here, polyline. With text, the problem is, again, it has to be in the 3D elevation. If it's not in the 3D, it's a problem. If it's only a text, there is a way to go around it, but it's quite, I will not have time to explain it. It's to take the text itself or even the block, the content, and project it on the level. These are heavy things, and I will not have time to show. So, okay. 55 points were filtered. Let's see them. It's a lot of entities. Okay. See? Points on each vertex. And now, let's update the surface. Now the surface will be updated according to these 55 points. And obviously your contour lines will be more accurate. Yeah, that's it. Okay. I'm summarizing the subject. If you are getting a file from a third party and you want to use it, you use filter. The best thing is to filter the points and the breaklines. But again, if are not in 3D, then you have no other choice but to work with the contours and filter the contours into points and then create the surface. Last item today is what we call LandXML. Let's assume that you have a surveyor in your organization. He's creating a surface using CivilCAD or even another software. And you are not a surveyor. You want to receive the surface. You said the problem of the surface is the surveyor. I want to receive the surface from him and not do all this filtering and everything. For that, we have what we call LandXML. And I will do it very quick because I don't have much time. Okay, and here I don't have a coordinate, I don't have anything. I want to receive a LandXML. I received the LandXML from a different software. I'm going to the surface, right click from the LandXML file. Here is a LandXML that I received. I read it. And now I'm telling the software, rating a surface, let's say each 0.5 meter, and show me the triangles. That's it. Don't extend. See? Again, I received the LandXML. I can continue. It's a surface now. I can continue working on it. I don't need coordinates. I don't need to do filtering. I don't do anything. But I will need that my software will have a software that can create LandXML. In CivilCAD, if you want to create it, you stand on the surface, you right-click, and you export to LandXML. So, for example, if I do the project that I did before, I can do the project, create, fine-tune my surface, go here, export to LandXML, and then give it to someone, and he can continue his design or volumes calculation, whatever he wants. He doesn't need to do filtering, he doesn't need to do anything. He just use the LandXML file. So again, what is the LandXML? LandXML are surfaces which you can transfer the surface itself as what we call BIM. I don't want to go too many things, but obviously CivilCAD is a BIM software. So take the BIM, the surface itself, and move it from one to each other. You don't need to give him the project. He doesn't need to DWG, doesn't need anything. Just the surface, and the surface is the problem of the software that created it. Guys, I hope you enjoy it. I hope you enjoyed the seminar. We'll do another university. Of course, we will share the recording. We will do another session probably in 1 or 2 months. And stay tuned. I hope you enjoy it. Thank you very much and enjoy the rest of the day. Bye-bye.